Have you ever written some code that, worked perfectly, right up until the moment you had to change it? Yeah, we've all been there. Today, we're going to look past those quick fixes and temporary patches. We're going to dive into what it really means to be a software craftsperson, how to write code that doesn't just work now, but is truly built to last. I mean, this cartoon just hits the nail on the head, doesn't it? You open up a file, and it's either a pew, okay, I get this, or an instant headache. Our goal today is to give you the tools you need to stay on the good side of the store, writing code that's actually a pleasure to read, not some impossible puzzle. And that really gets to the heart of the issue, this works but fragile problem. You know exactly what I'm talking about. The code that passes all the tests, but you are terrified to even touch it because you just know something will break. This is what happens when we fall into the trap of accidental programming. This quote from the book, The Pragmatic Programmer, says it all. Don't program by coincidence. It's that awful feeling when your code works, but you're not 100% sure why. Because when that code eventually breaks, and believe me, it will, you're left trying to solve a mystery you created for yourself. So, what's the solution? Well, it's not about learning the hot new framework or memorizing every bit of syntax. The real solution is a shift in how you think. It's about moving from just learning a language to really, truly understanding the fundamental concepts that power all of them. And this right here, this is the key. Languages are just tools, right? They come and they go. But the ideas underneath, things like algorithms, data structures, design patterns, those are timeless. Once you get a solid grasp on these, you can pick up any new language and just ask, okay, how do I do this concept in this new environment? It's a total game changer. Okay, so how do we start putting this into practice? Well, the very first, most important idea is writing what we call clean code. And this isn't just about making things look pretty. It's about making your code easy for other people and, let's be honest, your future self to understand. You've probably heard it before. Code is read way more often than it's written. But clean code can feel a little fuzzy, can it? What does it actually mean when you're staring at your editor? Luckily, some of the smartest people in our field have given us some really solid ways to think about this. So you've got Bjarne Stroustrup, the guy who created C++, saying it should be elegant, efficient, and do one thing really well. Then Grady Booch compares it to well-written prose. It should be simple and direct. And Dave Thomas brings it all home by focusing on maintainability. Can someone else pick this up and work with it? You see the pattern here, right? It's all about clarity, focus, and having a little empathy for the next person who has to look at your work. All right, let's get into our first big principle, and this one might be a little controversial. Let's talk about comments. Here's the thing. The best code is so clear that it doesn't even need comments. If you find yourself writing a comment to explain what a block of code is doing, that's usually a huge red flag that the code itself needs to be clear. And here is a perfect example of what I mean. On the left, you've got this comment trying to explain some logic. But on the right, we just pulled that logic out into a function with a super clear name, is eligible for full benefits. Now the code just documents itself. The comment is totally redundant. And that last example leads us perfectly into what might be the single most important part of writing clean code, naming things. A good name instantly tells you the purpose of a variable, or a function, or a class. It makes your code 1,000 times more readable. I mean, just look at this. On the left, the variable d tells you absolutely nothing. You need that comment to know what's going on. But on the right, elapsed time in days is crystal clear. Seriously, don't be afraid to use longer descriptive names. The clarity you get is worth it every single time. So, we know what good code looks like, but what about the code we've already written? How do we spot the problems? For that, we can use a really cool concept called code smells. Think of them as warning signs that tell you a deeper design problem might be hiding just beneath the surface. Now, a code smell isn't a bug. The code still works. It's more like a weird noise coming from your car's engine. The car is still running, sure, but that sound is a hint that you might have a bigger problem coming down the road. It's a signal that your code could be better designed. Here are a couple of the usual suspects to look out for. You've got bloaters, those massive functions or classes that have just grown way out of control. And then there are dispensables, bits of code that just don't need to be there, like that same chunk of logic you've copied and pasted into 3 different files. Learning to spot these smells is the first step to cleaning up your code base. Okay, so spotting problems is good, but you know what's even better? Preventing them in the first place. And this is where the solid principles come in. This is a famous set of 5 design principles that help you build software that's way easier to maintain and extend over time.
Let's just do a quick flyby of solid, okay? The S stands for single responsibility. Basically, every piece of your code should have one job. That's it. O is for open/closed, which is a fancy way of saying you should be able to add new stuff without breaking existing code. The other 3 get a bit more technical, but they all boil down to this one idea: create a flexible system where a change in one corner doesn't cause a cascade of bugs everywhere else. It's a deep topic for sure, but these principles are an amazing roadmap for building solid software.
Okay, we've covered concepts, clean code techniques, and design principles. The last piece of the puzzle is turning all this knowledge into actual habits. This is about the day-to-day discipline of being a professional, pragmatic programmer who's always improving their craft and their code base. So what does this look like in the real world? First, refactor all the time. As soon as you see a code smell, clean it up. Second, keep refactoring separate from adding new features. Clean the house first, make sure all your tests pass, then add the new furniture. And that leads to the most important habit of all, testing. A great test suite gives you the confidence to refactor without fear because you know you haven't broken anything. And in the end, it really all comes down to this one question. It's easy to write code that just works for today. Anyone can do that. But the real challenge, the mark of a true professional, is writing code that is truly built to last. So the next time you sit down to code, ask yourself, am I just getting this to work, or am I building something that my future self and my entire team will actually be grateful for? Thanks for tuning in.